Okay, I think we are live. Good evening, everyone. We're a couple of minutes early tonight, but that's okay because we're racing against the clock a little bit. It's a gorgeous, warm, calm evening here in the Death Valley region, and but the forecast call for some clouds to be moving in this evening, and it's been clear all evening so far, but about an hour ago you can see the clouds starting to creep in from the southwest. So we're going to certainly, and luckily what we're looking at is kind of high in the north sky, so we will have some extra time, but eventually I suppose we're going to get clouded out here, so we'll just kind of get to it, I guess. So let's get that off, and so right now I'm on our my alignment and focusing star, which is CAF, which is the very top star in Cassiopeia. So if we go to right here, and I need to undo all that stuff. So this is Cassiopeia here, where we are tonight. Right there, that famous lazy W in the sky, and so I used CAF as my my star to set up and align on. So let's just see what we can see. Go to the first one, Caroline's Rose. This is a good one. This is a good one to start on. So let's zip over there and see Caroline's Rose. It's a gorgeous cluster of stars. Okay, there obviously is our cluster. So let's increase our exposure and see what we can see. I'll start with 8 seconds of exposure because why do I have 2 of these? I don't know. 8 seconds of exposure probably will be about right for the brighter star clusters and things. Usually, I want to actually put in here what we're doing. Caroline's Rose. There we go. Now we'll start the stack again and reset all of this for the night and see where we get to. Can get rid of those crosshairs now. And we can bring these in, increase our brightness quite a bit so you guys can see some stuff. It's quite a brilliant and dense cluster of stars. Oh, and I really should adjust some of those colors too, because they're quite a bit whacked. Yeah, that'll look a little bit better. But it's a gorgeous little cluster of stars. And darken that background sky a little bit. Tonight we do have a little bit of about a 20 or 25% moon in the sky, I think. So the sky is a little bit lighter in the background, but which is why I started a little later than normal. Normally in the winter time, when the nights get dark nice and early, I start earlier, but we're heading into moon time right now, so the moon is in the sky later and later every night. Tonight here it doesn't set till about 10 past 9, and so for the first hour or so we're going to have some moonlight in the sky. So I couldn't start too early, but yet with the clouds rolling, and I couldn't start too late, so it's kind of a juggling act. But Caroline's Rose, great little cluster, pretty dense cluster of stars there. And now there is some nebulosity with it too, I think. Screaming Skull cluster. Whoa. Okay. Herschel Spiral Cluster, Crab Cluster, Screaming Skull Cluster, Star Mist Cluster, and Ghost Cluster, on top of being called Caroline's Rose. So this clearly is a busy asterism up there. It's been discovered and named by a lot of people. It's so dense, it's actually better to just look at it in context with the surrounding stars. But it's quite the dense patch. Screaming Skull. Don't know if I see the Screaming Skull part. I don't know, is that a mouth? Maybe a forehead or something? And a nose? I don't know. Let's make sure we got the... Yep. Okay. Flats are in. You are reset. Yep, everything looks right. Gotta remember to keep it bright for you guys, so that you can really see it well. Yeah, now you can actually see a little bit of a red nebulosity in here, because there is a little bit of nebulosity behind it, which is, I think, how they got the rose name for it, because there's a little bit of red that you can see. Hopefully you can see it. It's pretty faint here, but or maybe I'm just seeing a reflection from my red light, which is also possible. Hey Scott, good evening. How's things in Santa Cruz? Glad you're here. Let's push the stretch a little bit more. Brighten it up a little bit more. So you guys can see it a little better. Definitely a dense conglomeration of stars, but no real core like in a globular cluster. Globular clusters tend to have the really bright cores, and then as you go out they get more and more dim. This just seems to be a pretty even, dense concentration of stars. I wonder how far away it is. Do they know? They don't say. They don't say. Suppose I should bring up my trusty Wikipedia. $77.89. Let's try that. NGC 7789. Yeah, also known as Caroline's Rose, but it wouldn't show up in the discovered by Caroline Herschel. Oh, no wonder. Her brother William Herschel included it in the catalog. The cluster is known as the White Rose Cluster or Caroline Rose Cluster because when seen visually, the loops of stars and dark lanes look like the swirling pattern of rose petals seen from above. Well, it's a gorgeous cluster. That's for sure. I guess there is kind of some swirliness in here, isn't there? Cool. Okay. Well, let's save that one. And move on to the next. Alright, so who's going to be next on our little tour here? And we've got a few down here. NGC 7790, another little cluster, the Widow's Web cluster. Alright. Widow's Web cluster. Let's see if we can see this one. And we got a couple of little clusters in here. Looks like there's a couple of small clusters in here. Boy, there's so many stars in this area, it's hard to tell what's what. This Cassiopeia is in the arm of the Milky Way, so it's in a very dense star field. So, but I think this is it here. And then this is probably, yeah, this is NGC. See, and what's happening right now is my scope is, because of the way my mount is, my scope is actually upside down. And so, upside down and backwards. Yeah, see, so this is how it's organized here. This upside down and backwards with the two big bright stars here, and here are these two bright stars, probably here and here, or perhaps here and here. But anyway, this one down here is NGC 7790, and this one up here is NGC 7778. So two little clusters kind of in one view. So we'll do NGC 7790. That's what I said, right? Yeah. And so there's kind of two of them right in there in one spot. Okay, so let's clear this one out and start the next one. And before you do that, nope, you need to reset this, and then you need to go up like this, and then you need to reset this. That'll work better. There we go. There's those two clusters right in there. Actually, looks almost, yeah, looks like even a third one down here in the bottom corner. So 1, 2, 3, a string of them. 1, 2, 3 here. So 1, 2, 3. This that may be. Yeah. So 1, 2, and then 3. So this is CR 458. I think that's. No, that's in the wrong direction. So that would be off. That would be up. CR 458 is up here. So I guess this one is just this group of stars here. That almost looks like another cluster there, though, doesn't it? But I think from our star patterns, it's pretty clear that this is the one we're looking for. These two here are these two. And this one is just a random little group of stars, I guess. Or one that hasn't been classified yet. Heck, maybe we just discovered one. Hey Randy, snowing in Alberta in November? No. Say it isn't so. What is the world coming to? Gotta get the software out of the way here. Nice glistening star field. Oh, I know another thing I want to try too. I want to try and get the light shield on. So while this is loading, I'm going to go do that. Alright, anyway. For some reason I measured that the wrong way. Anyway. So, looks like we got these two coming in nice. that's pretty good there. Clear this and start again a little bit though. Scott, how is my image so stable, not bouncing with vibrations? Well, actually, several of the frames were ignored because I was bouncing the scope around. I have a filter set up on the image capture software that if it detects any sort of fuzziness in the image, if any of the sharpness of the particular sub-exposure that's coming in is messed up, it automatically drops the frame, so you don't bring a bad sub-exposure into your stack and ruin the whole stack. So while I was messing around with the scope, it actually did drop several frames, but it keeps the image there with the good sub-exposures. The stack is still there, but it was dropping some frames. So anyway, but the light shield is still on because I do catch a little bit of light from the neighbors, their porch light. So I just built a simple little foam light shroud that basically extends the nose of my scope another several inches, which should hopefully keep some of the background out. But these two are looking pretty nice. Cool. Well, so far the clouds are staying mostly to the southwest corner of the sky. They are moving in slowly, but if they stay down there, we'll be okay for a little bit. Alright. I think a couple minutes on this is pretty good. Let's see where we can see what we can see next here. Now I gotta... Okay, so we are out there, so we got to see all three of these. So now let's go to the next clusters, which are in here a little bit. So now we'll kind of go inside the first W. And see NGC 103. Lots of cool little star clusters here in Cassiopeia. Yeah, that looks like probably it right about there. Satellite zipping through according to the Planetarium software. Got 3 stars in a line here. And one bright star up there, which is probably this one. That's the interesting thing about using this this new telescope arrangement I have with the wedge, is that the images are often upside down, sideways, and everything else, and so it's hard to track on here what I'm actually looking at. So what I'm going to do is get my plate solving software up here, which is going to allow me to load settings 533. Should have the right, yep, it does. Okay, save those settings, and now I should be able to just hit the plate solve button on this. Although it may not have enough of an exposure to do it actually. Yeah, 8/800ths of a degree, so that must be it. The little one on the bottom must be it. Yeah, I have a feeling this one right here is what we're looking for. Come on. Wrong window. Okay. Let's put us out to 8 seconds. Undo the stretch. And start the stack. See what the stack will show us. Yeah, I'm pretty sure this is it here. We'll let it capture a few sub-exposures and let the background sky darken a little bit. I'm pretty sure this cluster here is what we're looking at. Yeah, just kind of a loose collection. That's a bright star there, that's a bright star there, which I think are these two. Very rich star field though in the Milky Way. Actually makes it hard to find stuff. Actually makes it hard to find stuff when you get so much there. Very loose though. Little concentration of stars, medium brightness, poor cluster with less than 50 stars. Yeah, that's about right. That's about what I'm seeing there. Just barely something that's big enough to show up as a cluster. Something that's just sort of a bright spot in the whole star field. But if we zoom in, you can really see that you can really see the individual stars that are in there. So, again, no defined core or anything, just a loose accumulation of stars. Alright. Nice thing about these clusters is don't have to spend a lot of time on them to see them. Kind of zip through them pretty fast. Okay. Let's go back to here and well, where are we going to go next? Looks like we're going to get another twofer down here. Zip down onto this one. We're going to get kind of two clusters again. Again, a couple of really loose concentrations of stars. Not really anything real bright. And it looks like kind of accumulation there. Not much there. Bright star to the bottom. These two bright stars. So you got a bright one here, two bright stars there, which is bright star, and these two bright stars. So, yeah, and we've got this here, which is this lineup of stars right here. And so our cluster is right next to that, so this would be our cluster right there, which is NGC 146. Alright. Clear out the old one. And I gotta unstretch this because it'll never work if I don't. Clear that again. And I also forgot to go up in my stack, so we gotta clear it again. There, now that should be everything right. 8 seconds, no stretch. Good. There we go. That's looking much prettier. Yeah, so we just have a nice little line of stars here. And sort of, it's kind of two clusters here. One here and sort of one there. Just little dense puddles of stars. And you can see we're right on the edge of the star field, because up here at the top you can see where the star field just drops right off. The concentration of stars just drops, which is kind of getting off the arm of the Milky Way. So we're probably right on the edge of the Milky Way here. Yeah, the arm of the Milky Way is right in here, and so we're kind of just skirting the top edge of it. Well, I guess actually in this case the bottom edge of it, because I've got that inverted. But you can see the Milky Way, the arm of the Milky Way going through here, and we're right on the bottom edge of it. But my telescope is literally upside down right now, photographing this stuff. So that bottom edge right there shows up at the top of our image, but that's the edge of the actual arm of the Milky Way, and we're tapering off into regular space, not space that's has the density of the arm in it. So we're just seeing the edge of the arm right there. There's actually kind of two in here. I don't think they have it indicated as two. Well, maybe. Well, no, they don't. Okay, so again, we have to match my image. We have to do this. But yeah, so there's kind of this group down here, and then the actual named group up there. It's kind of what we got there. And then this little lineup of stars here is right here. What they call NGC 133 is that little lineup of stars there. Little groups and clusters of stars. Well, time for some food. Coolies. All right. That's a good one. We'll save that one. And who's next? So we went down a little bit on that one. So yeah, let's head back up to our Cassiopeia and kind of do these guys. So NGC 225 sailboat cluster. Alright. .225 sailboat cluster. Boing, boing. Okay, well there it is. Yeah, so there's that line of stars there, and then we got this group here. Alright. So that looks pretty much dead on. So we'll just undo the stretch. Go out to 8 seconds. Start the stack. Clear the old one. Sailboat, huh? Does anybody see the sailboat? Wonder if that could be the sail. One of the sails puffing out. This is kind of a neat little collection of stars. Don't know that I see the sailboat part, but they are pretty stars. Let's see if we can stretch that a little bit more. Get that one. Earthquake? Question mark? Scott asks. I'm not sure what that means. You're having one? You think I'm having one? It's pretty neat though. NGC 225, alright. Save that one. Let's see what's next. NGC 189. Just a regular old open cluster. Yeah. Again, probably not. Yeah, it's probably this here. Probably not a very big cluster there. Where are those three stars? Seeing a line of three stars right here, which is a pretty clear. What if it's these three? I don't know if this one's going to be a real clear clear asterism, but what is this one? 189. Well, let's see what this one shows us. Yeah, again, we're in a pocket. In a pocket where the Milky Way thins out a little bit, so we're seeing actually some darker pockets here. Which is either stars thinning out, or it's some dark nebula that's in there. But you can kind of see the concentration of stars here. And there's this quad of stars down here, which is this right there. So I think we're pretty much on it. It's this right here. Is NGC 189. Yeah, got some nice colors in the stars too. This one's pretty yellow and this one's pretty blue. Different colors of stars in here. Kind of hard to see it in all that background of Milky Way stars, though. And that's why we're not going to spend a whole lot of time on each one of these. They're interesting, but a couple of minutes usually is about good enough. So that's NGC 189. Alright. Invert the view again. And let's see, okay, so 129 is next. We haven't done that one yet. Alright. Let's see what that one is. Yeah, a little bit more defined of a grouping in this case. We got 129. 129. And clear and start over. Yeah, kind of a pretty little cluster there. That's much more of a defined cluster than what we've seen up to now. What does the stack mean? Well, what I'm doing right now, let me close the full screen for a second, Tara, and I'll show you. You can see down here in the bottom right-hand corner a progress bar. This is a progress of each of the 8-second individual exposures that I'm taking. So with the camera that I have stuck in my telescope right now, I'm taking a series of 8-second exposures. And what this software does is, as it takes an exposure, it takes that new exposure, aligns the stars of that exposure with the stack of exposures that are already there, and adds it onto the stack. And then it takes the next one and does the same thing, aligns it, and adds it onto the stack. And with the more sub-exposures that you add to the stack of images, the more the signal-to-noise ratio improves. So bright things get brighter and dark things get darker. And so when I refer to subs or sub-exposures or frames, that is the individual exposure that I'm talking about, and then the stack is the accumulation of all of those individual sub-exposures that are being added together to create a stack of images that creates the final image that has, hopefully less noise. Speaking of less noise, there's a couple things I've forgotten to do here. I didn't turn this on, and I didn't turn this on. Bummer. Oh well. And so what they do is they, as you add more frames or more subs to the stack, the image quality just significantly improves and improves. And it is a modern alternative to astrophotography, where they would get a really big expensive scope that tracked really accurately and open the shutter on the camera, stick it in the eyepiece, open the shutter on the camera and leave the camera open, leave the exposure open for minutes or even hours at a time with a telescope that can track very, very precisely. And so that's how traditional astrophotography is done. But now with modern digital cameras and software, it's turned into something called EAA, or electronically assisted astronomy, where instead of taking individual sub-exposures of many minutes in length, what you do instead is you take many, many very short sub-exposures of a few seconds in length, or in this case 8 seconds, and you stack them all together. And you stack them together for a few minutes, and essentially what you get is an image that's just as good as if you had taken a single exposure for, we'll say, 3.5 minutes. Now right now you can see I've taken 27 stacked images down here on the bottom, 27 stacked images at 8 seconds each, so it's 3 minutes and 36 seconds is the total integration time of that stack, or that finished image that you're seeing here on the screen. This is the result of all that. And so this is actually not only the equivalent of a single image if you had held the exposure open for 3.5 minutes in a telescope with a camera, but actually there's quite a bit of evidence that the signal to noise ratio is actually better on a 3.5 minute image that's made up of short exposures than a single exposure of 3.5 minutes. So anyway, that's a very long-winded explanation of your question and probably told you more than you wanted to know. But yeah, when I refer to subs or frames or sub-exposures, those are the individual exposures that you see down here with the progress bar that the camera is taking and the software is processing, and the stack is the whole stack of images that's giving us the resulting picture that we see here. So that's come out pretty nice. So I think we'll save that and move on. NGC 129. Okay. And we're almost done with, and actually, now that I have actually turned on the sharpness, I want to go over and do Caroline's Rose again really quickly, because that is a really good one, and I want to get a better image of that, because I didn't have any of the sharpness controls turned on, and that's a good one. So we're going to take one more quick look at that. Let's get it centered up a little bit. There we go. Come on. Come on. Move over there. Mount is getting a little bit finicky. Alright, that's pretty nice. 1, 2, 3. Here, do I have that? No, I don't. Yeah, I'll do this one again real quick, because this is a good one. I want to catch a good glimpse of this with the sharpness on. We'll be able to see it more clearly. See some of the structure more clearly now that I have the sharpness tools turned on. Yeah, that's about right. Actually, while this is stacking, I'm going to go toss my jacket on. So I'll be right back in just a second. Okay. Yeah, that's coming out quite a bit sharper, I think, than the last time. So, Carrie. Hi, Carrie. Thanks for coming by. This is brilliant. Thank you. Thanks for sharing. Quick question: Are you guiding to get such sharp images? No, Carrie, I'm not. Actually, I'm not even using an equatorial mount. I'm just using a pretty precisely polar aligned AltAz mount on a wedge. In fact, while this is doing that, I can actually show you guys my setup here. Let's see. Where are we here? Let me show you a picture of what I'm actually using. So this is my actual setup that I have here. And so this is my spare no expense concrete block pier and wooden wedge that all of which I built myself with just stuff I had here on my landlord is a pack rat, so this stuff was just all sitting here as scrap, so I pretty much just cobbled it together to make my setup. And then this is just a Celestron Evolution AltAz mount that controls the telescope that's mounted to it up here. And so all I do is the blocks and wood part, the wedge and the pier, stay outside. Those are precisely polar aligned on the north central pole, and they just stay outside all the time. And so the only thing that comes in with me is the telescope comes off the mount, and then the mount comes off the wedge. You can see there's I bought 3 knob bolts that mount to the wedge, the wooden board wedge. And so the wedge and pier stay outside all the time, precisely polar aligned. And the only thing that I have to do is put the mount and the telescope on it each night and star align it real quick, and I'm ready to go. And it's precisely polar aligned enough that it tracks very well. You know, modern mounts, even inexpensive AltAz mounts like that, nowadays track really well. And so between that and the great job that SharpCap, the software that I use to stack the images with, does such a great job with the stacking process that the images come out nice and sharp. And you can see, even zoomed in, the stars stay pretty round. Of course, I'm only doing 8-second exposures right now, so that's not much of a test to it. But I've gone up to 32-second exposures, and everything tracks pretty well. So, but this is a much better capture of Caroline's Rose. And I don't know if we can actually see the. I don't know the flowing parts of it, but there are some interesting lines and flowy parts to it, I suppose, but I never really have seen the rose in it. But yeah, well, there you are. But that's a good capture there. So I think we'll just take that as is. Stop our stack. Now that I got a better one of those. And okay, so we've done all these down here. So let's go up over the top. I believe we've got one more to do up here on the top, which is this one here. This is an open cluster. So let's zip over it and see what that one looks like. Oh, it looks like there's a little nebulosity to it. IC 1590. All right. I have a feeling it might be this down here. Let me put a few more seconds on the exposure. See if I can see it better. Yeah, that's got to be it, because you can see the nebulosity down here as well. So that's got to be it down there. Alright, so let me bring that up and center it a little better. Bring it a little bit more to the left. Come on, your other left. There you go. That's probably good. Let's see. This is IC 1590. Alright. This one possibly. Oh yeah, no, I thought maybe we'd have to do a longer exposure than 8 seconds to see some of the nebulosity. But apparently not. Actually, yeah, this is looking like, I think this is Pac-Man. It's looking an awful lot like Pac-Man. Let's check the trusty Wikipedia. IC 1590 is an open cluster. The cluster is estimated to be 3.5 million years old. Making it relatively young compared to other star systems. Inside the cluster are the multiple star systems of emits light, which helps give the dust in NGC 281 its glow. Yes, okay, NGC 281. All right, yeah, that one I recognized. And so the cluster is actually the eye. This is actually the Pac-Man nebula, because it looks like Pac-Man with the eye and the mouth. But that's NGC 281, and which is why I didn't recognize the IC 1590. IC 1590 is the actual cluster that makes up, that gives the Pac-Man nebula its glow. Yeah. So this one we might let go for a little bit longer. This is one of those targets that would that's a good one to do after the moon sets, which is just about another 10 or 15 minutes or so. So the sky is pretty dark. It's not too bad. But this one we could probably let go for a little while longer to let the nebulosity kind of come forward a little. Yeah, I like the nebulae too, Tara. It's a lot of fun. There's a lot of colors in that, and It's fun watching it get sharper and darker as it continues to come in. Let's make sure we're all good there. We are. Okay. Make sure those colors are right. No, the colors need to be balanced again. Doink. Always gets too much blue. I'm going to tweak the red up a little bit. Give it a little bit more red since the Pac-Man is red. Stretch it. Come on. Stretch it a little bit more. Give it a little more oomph. But yes, this is the notorious Pac-Man nebula. Which means I assume it wasn't named by Galileo or William Herschel or Charles Messier. Because I don't think they quite had Pac-Man developed yet then. So this must have been named something after the 80s. Again, tucked away in a rich star field. I see a very dark center. And then lower to it on the right is a very bright part. Do these have names? Very dark center. I guess I'm not sure what you mean. You mean in the whole image itself, or do you mean just in the nebula Terra? Like an eye, you mean the eye of the Pac-Man itself, which is a little star cluster that we're kind of focused on. I guess I just don't know which bright parts and which very dark parts you're referring to. Basically, in this picture, there are kind of two asterisms that we're dealing with. Number one, the eye of the Pac-Man here is a star cluster called IC 1590. And then the nebula itself is called NGC 281, or the Pac-Man nebula. So those are really the only two things that have names in this particular asterism. If I increase the exposure length, I would probably get more of the nebulosity out, but it would also blow the stars out a bit. So this is kind of a balance of things. maybe we'll come back if we have some more time. Once the moon has set, maybe in half an hour or so, we'll come back and look at this again. Maybe do a higher exposure, a longer exposure subs on this to see if we can bring out some more of the nebula itself when the sky's a little bit darker. But for now, I think that's pretty good. Almost 9 minutes on that. All right. Oh, I was doing 16 seconds on that. Haha. Okay, I didn't realize I hit that extra time. So we were actually getting longer exposures on that than I had planned on doing, and I had the wrong dark installed as a result. So anyway, I think we're going to come back and do that one again anyway once the moon has set. That's a good one to do when the sky's as dark as possible. So in the meantime, let's do the dragonfly cluster, NGC 457. NGC 457 dragonfly cluster. Okay. Yeah. Oh, look at that. Yeah, this I can actually see the dragonfly. Yeah. Okay. Let's move the dragonfly a little bit more into the center. Yeah, let that settle for a second. I'll synchronize this a little bit closer. Whoa! Boy, that jumped. Not sure why it did that. That back over. There, that's pretty stable. Okay, let's try this again. I don't know why that jumped. Okay. Anyway, the dragonfly cluster. Let's see what this one looks like. Yeah, we're going to need to adjust this out. Blacks are all clipped. Yeah, that's better. And that's better. Ha! This one there may be too many stars. Actually, in the planetarium, you get this is kind of like the eyes and a wing here, and a wing here, and the body kind of going back here and a tail. So I can actually see the dragonfly in this one. You can actually see it better when it's just the bigger stars. A shorter exposure actually would probably show the dragonfly a little bit better. In fact, why don't I try that? Let's see how it looks at 4 seconds. Let's drop it out and see how it looks at 4 seconds. Probably gonna need to bring this all the way back to see it though. We get somewhat less of the stars. We only see the more major stars in it by having the shorter exposure. It's a neat little one though. Let's push the stretch a little bit to brighten it up. Brighten it up some. Let's see what Wikipedia has to say about the dragonfly cluster. Owl cluster. Oh, it's also, oh, that's right, this is the owl cluster, right? Because of the eyes. These two are the eyes in the dark, the wings of the owl. Or Kachina doll cluster, or ET cluster. It's discovered by William Herschel, 1787, lies over 7,900 light years away, has an estimated age of 21 million years. Or the skiing cluster. Next brightest star is the red supergiant. V466. Okay, so right here, this right here is a red supergiant. So this star right here is a red supergiant, which is a star many, many times larger than our own sun. So that's kind of cool. The red supergiant star. You can kind of see it's a reddish color. Zoom in a little bit here. See, this one's pretty blue, and this one's a whitish yellow, and then this one's got a little bit more of an orange tinge to it. Owl cluster. Oh, just saw a shooting star. It looks like the clouds so far are holding off on us, so that's a good thing. They've actually even kind of receded a little bit, which is great. May get a full night in here. Or at least until I get cold and hungry. Owl cluster, dragonfly cluster, ET cluster. What else is it called? Skiing cluster. Kachina doll cluster. Guess you can pick your favorite. Well, thanks for stopping by, Carrie. Really appreciate it. Glad you had a good time. That's kind of a good one. It's kind of a good one there. Owl cluster. Okay. Save that one. And stop the stack. Alright. And now, who's next? What do we got here? This one is, I think, going to be, yeah, it's a nebula, so that's a good one to save for a bit. So let's go ahead and do well, let's just do M103. So this will probably be M103. So the 103rd item on Charles Messier's list of things that were not comets, which is kind of funny. Charles Messier was a comet hunter, an 18th century comet hunter, and he would roam the sky nightly for comets, and he kept running into these bright things that weren't stars, so he started getting frustrated at seeing all these same things all the time. 1, 2, 3, and wondering if they were comets, and no, they're not comets. And so he said, okay, I got to make a catalog of these brighter things I keep thinking that are comets, and I keep getting confused because they're not comets. And so he started making a catalog of things to avoid, things that weren't comets, and developed a list of 103 things or so, or 101 things in the sky that were kind of the brightest objects out there that weren't stars and weren't planets and they weren't comets, and he just wanted to make sure he avoided constantly seeing these things. And so he made this catalog, and well, what he ended up doing in a backwards way was kind of presenting a catalog of some of the nicest objects in the sky to observe. The nicest deep space objects to observe. Star clusters, galaxies, nebulae, all kinds of things that were these bright objects. They were bright enough to be interesting. They were bright enough to constantly catch his attention, but they weren't comets, and they weren't planets, and they weren't other, the more familiar things. And so nowadays, the Messier list is used by amateur astronomers everywhere because it's just an extremely handy catalog of really nice, bright, mostly colorful, interesting to see objects. And so it's kind of the first, your first hurdle as an amateur astronomer to go through and do the Messier marathon and try to see all 103, which now is 110. I think he only made 101 or 103 on his own in the published catalog that he published. But since then, in recent years, scholars have gone through his notes and have found 8 or 10 other objects that he did observe and take notes on, but never formally added them to his catalog. So now the Messier list is actually 110 objects instead of the 101 or 103 that he originally developed. And so this is M103, which is a pretty little bejeweled cluster of stars here with some nice little bright shiny stars in it. But definitely not a comet. So it went in his catalog. Fun. Yeah, it's a good one. Anything on the Messier list is pretty much guaranteed to be a good one. Alright. Alright, let's see what's next. What we got out here? Object of unknown nature. Magnitude 14, surface brightness 20. Yeah, you know what? We'll pop over there, but that's awful dim. I don't know that I'll be able to see much. But we'll see. Object of unknown nature. Okay. How do I even know what I'm looking at? How do I even know if I found it? Yeah, there's not even any picture of anything in here. So, yeah. Let's crank up the exposure. See if we can actually see anything. Stack a couple things on it, who knows? See what an object of unknown nature doesn't look like. Yeah, well, it's definitely going to look like a big washout unless we adjust the histogram. Everything's going to have to go to the right. All right. First person to see the object of unknown nature wins the prize. I have no idea what it even is. Distance 978 light years away. They don't know what it is, but they know how far away it is? That's interesting. OOCAN. Object of Unknown Nature's new acronym. You get to be the first person to create an acronym. No, there might be other acronyms out there I've heard already. Could be making it up, though. But I guess we could call this the OOCAN object. Or the Terra cluster. Yeah. I don't know that we're going to see anything here anyway. Oh well. I don't think there's anything that we're going to be able to see, whatever the heck it is. Yeah, interesting. Anyway, back to our star clusters. Let's see what this cluster is. What, maybe this here? What are we talking about here? Wow, that's a pretty spectacular one down here. Okay, so we should have... Okay, yeah. So if these three stars here are these three stars here, and like, once again, we're upside down and backwards. This is actually what we're seeing right here. So there's the star cluster there, and then up here, just beyond these two stars here, which is these two, is this. So I think I'm going to just move the scope so we catch that too in one shot. Oop. There you go. Yeah, so we kind of catch both of them together. Kind of catch both of them together in one deal. Let the scope settle out here. Okay, that's looking pretty good. This is going to be what? The yin-yang cluster is what the bottom one is. Which is what? NGC 659. NGC 659. Alright. And we're going to need to probably adjust that again, because it's going to be a much dimmer object. Yeah, if we ever see it, Terra, we'll name it the Terra. We'll name it the Terra cluster, or something. You know, you get to be the first one. Of course, you have to actually find it first. So, that's the task before you. All right. So we got two clusters in this one. The big bright one up here and the smaller little NGC 659 down here. Definitely some redness in these stars too. Wonder if those are more red supergiants. Type star, circumpolar, yeah, blah 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 blah. Color index. Doesn't have them indicated as to what they are. But lawnmower cluster. So this upper one is called the lawnmower cluster, or the letter S cluster. Lawnmower. Well, I can kind of see the letter S in here, maybe like as a backwards S. Lawnmower. Don't know that I see a lawnmower in there. Don't know that I see the lawnmower bit. But definitely a couple of pretty little clusters, though. Yeah, I got it Monday in. It took me a second, but yeah, Monday in. Mundane. Oh yeah, Monday in. Yeah, mundane. Yeah, it seems a bit utilitarian for such a, pretty cluster, but I don't know. I'm not sure how they get a lawnmower out of it. Oh well. You know, when you look up at the clouds, everybody sees different animals. So astronomers, when they look at star clusters, they can see whatever shapes they want to, I guess. Well, that's kind of a fun one. Alright, we'll save lawnmower. We'll save the lawnmower. Alright. So we got those two. Oh, and I'm back to being warped out here. Okay, so we've done M103. We did the strange and unusual... No, I'm sorry, the Terra cluster. Yeah, we did the Terra cluster up there. Alright, let's see what... The fuzzy butterfly cluster. Alright. Fuzzy butterfly cluster. Let's see. Alright, yeah, scan in there. This is going to be what? NGC 654. Doink, 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 doink. Fuzzy butterfly. Fuzzy butterfly. Cool. It's a neat little cluster. Alright. Fuzzy butterfly cluster. Alright. Whoop. Too far. Okay. And now we've got a couple more down here. Caldwell 8, another open star cluster. Let's see what this one looks like. Yeah, it's kind of a nice cluster. Nice little grouping there. Five, 9. GC 9. All right. Yeah, kind of a nice cluster here. Interesting star colors too. A very blue star here. Very yellow, orange, reddish one here. To 100 stars. 50 to 100, huh? Yeah, it could be. Some of these stars look round and solid, and some of them look smeared. GC 559. All right. Stop that stack. This 609, another open cluster. Just spending 609. This one doesn't look like there's a whole lot there. Yeah, just a little guy, huh? Wow, yeah. Let's try. It's going to be right above a couple of stars. Oh, there it is right there. 1, 2 with a third one in the middle. 1, 2, a third one in the middle. And there's the little cluster right there. Okay. Center it up a little bit better in our view here. Alright, probably about right. Synchronize our mount here. Okay. This one's just a faint little guy. Yeah, just a faint little cluster in there. see, 609. So, Tara asks what an open cluster means. There are two general kinds of star clusters. One is an open cluster and one is a globular cluster. Open clusters are clusters of stars that are kind of clumped together, but they have no defined core. So they're just kind of everything we've seen tonight so far has been an open cluster. It's just a group of stars that has no defined core. And actually, this is kind of interesting. Look, it's got an eye there and an eye there, and a face here, mouth there. It's almost like a little dude in here. Nose right there, mouth there. I'm surprised this doesn't have a name. It's kind of some pretty defined stars. And so a globular cluster is going to have is going to be a much more defined core. Let's see. Let's see if there's any globs in the area here. Do I? Oh no, you're upside down again. Don't forget. Okay, now we're up. Okay, right side up here. Let's see if I can find, because we'll find a globular cluster and see if I can find one close by that we can take a look at. And I'll show you what a globular cluster looks like. Here, globbies. Where are you? Well, there's one way over here, but that's too low. So we're looking for these kind of symbols. And M71 is also one, but again, that's too low. There's another one down there, way too low. Boy, there are no globs around Polaris, huh? Okay, here's one over here. It's about 20. Which one is this? It's not a very bright one. It's the closest, but it's not a very bright one. It's probably not a great example. Well, if that's the one we look at, that's the one we look at. I think most of the other ones are probably already set. Where's a glob when you need one? That one's also too low. And that one's, and this one in the southern. See, M15 is now, M15 is a great glob. And it's, well, it's over in the, can I see it? It's over almost due west. I don't know that I can actually see that one, though. Because it might already be set. Yeah, it would be tough. Yeah, that one's already, unfortunately, this is just in a roof line. That's a great glob to look at, but that one, unfortunately, just went into a roof. So I can't quite see that one. Yeah, it's near Enif. Enif is just about to set into my roof, so that's not going to work. So those are all too low. Well, I think this is the only one we can actually see. Yeah, we've gone around the whole sky here. I think this is about the only one that we're going to see. Nice near Castor and Pollux. Where are you guys? Capella's way up there. Oof, I wonder if I can actually... That might actually still be in a roof line as well. Yeah, thanks, Zen. I am having fun. Glad to see you could join tonight. Mom must be letting you stay up late. Well, this depends how long we're going to be around, but this is going to be coming up. Where is Castor and Pollux? Are they even up yet? Yeah, I don't know. Those still haven't cleared a roof line, so one is just we're a little too late for. The other one we're a little too early for. And there isn't another globular cluster up in the sky. But if we can find one, we'll take a look at it. So far, no luck. Might be able to see it. Well, in any event. But this is kind of a cool little dude. I mean, he's got clearly some shape and eyes and mouth and nose and... Well, I'm going to go take a look at we're going to see if we can see the other one. It might have already cleared my roof line, that other one, so we'll see. It's not going to be... This one here is not a very bright one, but it might be good enough for our purposes to take a look at. Okay. So that's what we are on right now. So let's see if we can't zoom over and see that glob. See if it's cleared my... Guess we'll find out if it's cleared my roof. As the scope whirs on its way on over there. Ooh, maybe. Maybe this might actually work. Can we actually see stars in here? Yeah, a little bit. I'm not seeing a glob though. Let's see. 1, 2, 3 stars. Alright, let's try doing a plate solve. Off by 3/4 of a degree. Okay. Let's see if it gets us there now. And there it is, right there. Really faint at the moment, but that's what we're looking for. Okay. Let's see. C25, C2419. 2419. I don't think I've ever imaged this glob before. Well, let's see what we can see with this guy. I did unstretch that, right? Yeah, I'm pretty sure I did. Yeah, I did. Okay, so that's just... Not going to be very big or very bright, but we'll see what we can see. It should be a fairly good example of one. We get the histogram adjusted here so the sky isn't all blown out. And do a color adjustment. Bring the blue way down. That's a little better. Okay. And so what we're looking at is this guy right here. You can see, obviously it's not a star. It's a pretty small one, so we're going to have to let this go for a few minutes. But what you're going to be able to see here, obviously there's a big difference between it and the stars that it's next to. It's a cluster of stars, but unlike an open cluster, it has a distinct core and a distinct concentration of stars near its center. Let's give it another minute. As we let more sub-exposures come in, you'd be able to resolve individual stars. Unfortunately, this is the only one that's up right now. There are some, like M15, which is the one that is just setting behind my roof, is a big, much brighter, spectacular one. This one actually is pretty dim and fuzzy and small. So it's not a very good example because it's kind of hard to see, but you get the idea. The globulars have defined cores and high levels of concentrations of stars in their cores. They tend to be globulars tend to be much greater numbers of stars than open clusters. There is some belief that globular clusters actually are probably they're probably captured galaxies that have actually come in and have been captured by the gravity of the Milky Way galaxy, collided with the Milky Way, if you will, and most of their stars have been stripped off, and the only thing that's left is the core of the galaxy itself, the very core stars that made up the galaxy itself. And so there are sometimes tens of thousands, hundreds of thousands of stars in these globular clusters in relatively tight concentrations. So hopefully this gives you an idea. Like I said, this is not a very good example of one. It's definitely a globular cluster. You can start to see the individual stars now coming out. But it's not a very good example of one because it's a pretty small and dim one. But in fact, let's try increasing the exposure. Let's try increasing the exposure and see if it improves things at all. Definitely got to brighten things up, but the question is, will it brighten everything up, including the background sky? Probably. See what happens as we bring more sub-exposures in. up this stack for a few. But this one is pretty small little guy. This one's a pretty tiny one. There are much bigger, brighter, and more spectacular ones out there, but just none of them happens to be up right now. We'll give this a couple of minutes and see what happens. Yeah, you can probably just start to see now that you make out the individual stars that kind of are making the cluster around the periphery, and then the core is pretty much just a bright glow where the concentration of stars is the highest. And so that's a globular cluster where you've got they're much tighter concentration of a lot more stars. Open clusters tend to be just groupings of stars, but they don't have any sort of focused core or a particularly high level of concentration like a glob does. But I don't think we're going to be able to get a very good it's not a great example, but I think it gives you enough of an idea to know the difference between them. It's a small little guy. That's one of the smallest ones I've ever seen. Almost gets, I mean, almost looks like just another star. I'll save that. Okay. Now, back to our exploration of Cassiopeia. Whoa. What the heck did you just do there? I think we were pretty much done with this stuff. Yeah. And so next I was gonna take a look at the Heart Nebula. See if we can see anything. Well, let's try NGC 1027. It's another open cluster. That'll give you something to focus on when I get over there. And then we can work on the two nebulae. Okay. Yeah, that looks like it's going to be it up there. Yeah, just kind of a loose accumulation. 4 little stars in a row there. Which I think are these 4 here. Yeah, with the bright one right, and if we do the Yeah, these 4 little stars here with that bright one there, or these 4 with that bright one there. So that's what we're looking for. Let's move it into the center of the view a little bit better. Maybe a titch more. That'd be about right. Okay. And then it jumps again. I don't know why it's doing that. That's good. Okay. Synchronize again. And oh shoot, what's the name of this one? This one is NGC 1027. 1027. Alright, let's stack that one up. Looks like the blacks are clipped, so I probably got the histogram out. Yep. That'll look better. Kind of a neat little cluster. The colors are a bit off though. 8. Where are you going? Let's try rebalancing the colors. Yeah, they're pretty much right on. Looks like we are seeing a bit of a red tinge here. The red from the nebula, so we're definitely in nebula territory here. Let me reorient this. Yeah, we're definitely in this. So this is the Heart Nebula here, and the Soul Nebula over here. So we're kind of right on the edge of that, which is why you're seeing this reddish, pinkish reddish color in here. It's the beginning of some nebulosity. That's kind of a fun one. You know, one more we probably should see when you're in the area of Cassiopeia. It's double cluster. Double cluster is pretty nice. And it's something that we can easily fit within. This is kind of a big spectacular, because in fact you can see it naked eye. I can look up and I can see it right here naked eye. So it's a pretty bright pretty bright cluster. Yeah, you can see both of them right there. Let me move it into the view. Just two distinct clusters of stars that are right together. Come on. There we go. These are pretty spectacular. Alright, double cluster. Kapoof. Bright and spectacular. Thank you, Tara. Thanks for stopping by. It's good to hear from you, and I'm glad you enjoyed it. This will probably be my last one for this dark of the moon cycle, since the moon is coming back into the sky now. But next couple of weeks, I'll be doing more. But this here is a good way to finish off too, because it's just got a nice big bright spectacular double cluster of stars. Like I said, this is so bright that you can actually see it naked eye, provided you have relatively dark skies. Right between Cassiopeia and Perseus in the sky. Yeah, so it's right, there's Cassiopeia there, Perseus over here. It's right between the two, right in the plane of the Milky Way. And it's good stuff. Spectacularly bejeweled asterism that's wonderful to see in binoculars. Even are great to see this, or even a small telescope is certainly good. But it's a kind of a spectacular one. That's pretty cool. Even after just a couple of minutes. That's all it really takes for that spectacular thing there. It's a beauty. It's a beauty to see double cluster. Doesn't take very long though, it's so bright. So big, bright, and beautiful, it doesn't take long to Alright, let's see if the Heart Nebula will show itself. For this, we're probably going to want to increase the exposure. Yeah, so we got a little bit of a cluster of stars in the middle of it there. The problem is it's actually too big for my, it's too big for my my scope. So I'm probably actually so this is just, we can try doing something here, but it's probably just going to be too much for too big. But okay, let's do a full 32 seconds on this. See what we come up with. Oh, and this is going to be Heart Nebula. Alright, yeah, we're going to need to adjust that histogram because it's going to be much bigger exposure, so we're going to need to have some pretty good adjustment here to back this off. Make it quite a bit darker. But you can already see that there's some nebulosity in there. You can already see the red and the colors. I'll let it collect a few sub-exposures, but you can see the nebulosity that's going to be all through here. So now we've jumped from 8-second sub-exposures to 32-second. So we're getting a lot more light here to try and pick up the faint background nebulosity. Getting some nice structure in there. Let's see if we can do some color adjustment. Let's pick up the red a little bit. that's coming along pretty nicely. I think that's probably going to be good. I'd like to move on to the Soul Nebula. So we'll save this one as is and move over there. So it's going to be a bit bluer. Okay, didn't I? Thought I turned that off. Guess not. Yeah, so that double star right in there. Okay, well, let's twine that up. Soul Nebula. I'll clear the heart out. Let's see what the Soul Nebula has here. Looks like we got a bit of a satellite or shooting star that just glanced through some point during the exposure. This one seems to be a bit fainter than the Heart Nebula was. And surface brightness of 1274, so it's much fainter. But it's definitely there. You definitely see the nebulosity all through here. That kind of ends right here. Well, it looks like this is definitely going to be the last one we do tonight because the clouds are now sneaking in. In fact, one of them snuck right over and past me somehow. But, yeah, the sky's looking a bit mushy right now. We definitely have some high thin clouds moving in, so we'll give this another minute or two, but this will be the end of the night. We're keeping good numbers. So I'm really happy we got in the time that we did, though, because earlier it looked like the clouds were coming in and then they just kind of stopped. So we got a nice reprieve to have a pretty good evening, actually. But now the mush is starting to move in and starting to get kind of crappy. So, but we got the heart and soul in. We've got a good couple hours in. I've been going for about 2.5 hours, so that's pretty darn good for a night where wasn't sure we were going to have more than an hour or so. But the clouds held off, so that's a cool thing. But yeah, I don't know that we're going to get much more out of this with the way the mushy sky is turning out. So I think I'm probably just going to save this and call it a night. Thanks everyone for stopping by and joining. Hope you had some fun, got to see some cool stuff. I know it was fun for me doing it, so I hope you had a good time. Like I said, it'll probably be a couple of weeks now before I do another one, because the moon is going to be dominating the sky now for a couple of weeks. It's moon time. Astro time is done and moon time is now here, and so we get to enjoy some nice moonlight for a couple of weeks, and then we'll be back to some dark skies and astro time. So anyway, I will sign off and see you guys next time. Thanks for joining, everybody. Good night from Death Valley.